I only have 5 minutes, keep it to a minimum. My name is Chris. I work at Facebook London, dealing with web server reliability and performance. So I'm going to be giving kind of a whistle-stop tour of the new version of control groups added in Linux 4.5. So don't worry if you don't have a clue what control groups are yet. I'll go over what they are and where you may have actually used them over the next few slides. So on a typical server, we have 3 types of running processes. On one hand, the core workload of the machine on a web server, for example, this would be the processes that serve web requests. And on the other hand, you have background processes like chef or metric collection daemons that, while they might be important, aren't actually critical to the core job that you're trying to do. And you don't want them to steal a lot of resources from your core workload. So you might also have, say, ad hoc queries being run for debugging. So this is one common scenario where control groups can be handy. Control groups have existed in the Linux kernel since 2008, and they've been a core part of allowing containers as we know them to exist. So control groups allow you to take a shared resource, say CPU or I/O use, and set thresholds for a certain group of processes, or limit those processes. For example, you might set a memory or I/O limit for your non-critical services to avoid these resources being stolen from the processes which serve web requests in the scenario I talked about before. So a C group can consist of as many processes as you like, which means that you can either apply these limits really tightly or to a single process, or more flexibly to a group of processes, for example, a group of processes that provide a single service from a user-facing point of view and generally act as one unit. So you might think that, hey, my favorite containerization product already provides this functionality. Well, you may be right, but if it was updated in the last 8 years, it's almost certain that it doesn't actually do this itself. It almost certainly does this using C groups under the hood. So let's go back to the limits that we described before, and here's how you would actually implement that in version 1 of C groups, which is the one which has existed since 2008. So the C group hierarchy is available at sysfs cgroup, and you manipulate it using the directories and files within. We don't have a syscall interface for this. In this case, we have 2 kinds of groups that we want to limit, BG for background services, and ad hoc for ad hoc queries, with C groups spread across resources. It's important to note that from the kernel's perspective, even though it's a common way of using it, and even though C groups across different resources may have the same name, they don't actually have any relation to each other from the kernel's perspective. This has some interesting implications, which I'll go into later. For example, here the ad hoc group exists both in the memory and PID resources, but those two are unrelated from the kernel's perspective. In C group version 2, we have a similar hierarchy, but this time it's a single hierarchy, not one hierarchy per resource. Here is the version 1 hierarchy again for comparison, and as you can see, it has a C group per resource. C groups here only exist in the context of a single resource. In version 2, this is essentially inverted. We no longer have a hierarchy per resource. Instead, we have a single unified hierarchy, and you can enable resources on a per C group basis with cgroup.subtree control. When you do this, files appear in this directory that we can manipulate to set limits and account for the usage of this C group. So why do this? Why break the API? Why create version 2 instead of improving version 1? Well, there are a few reasons which made this worth doing. Version 1 C groups generally work pretty well and have done for 8 years, but their design has some limitations. Many of these were caused because at the time that C groups was invented, typical modern use cases for them were not really very well fleshed out. This means that they often have some undesired complexity due to overflexibility. And addressing these issues is one of the main reasons that cgroupv2 was created. One other problem is that it was really difficult previously to track resources when doing cross-resource operations, which is actually pretty common in Linux. For example, when you write to a file in Linux, you don't actually usually write to the file directly, but you write dirty pages into memory, into the page cache, and then eventually pdflush or a similar kernel worker flushes them out to disk later in a kind of unrelated operation. This results both in resource usage in terms of memory when you've written those dirty pages to the page cache, and I/O usage when we eventually flush them back to disk. But in version 1, it's impossible to track these because these operations happen across 2 distinct resources, and we have separate C group hierarchies in each resource. So we can't make any decisions about what particular processes are in each C group, because even if they have the same name, it might not be the same process in each C group. In version 2, with the unified hierarchy, we can actually track these and apply them to accounting and limits, which gives better visibility and better usage. Version 1's overflexibility also contributed to a number of API problems. For example, when limiting memory in C group version 1, there were separate memory limits per memory type. This meant that you get crazy situations like if you set a limit on socket buffer memory and you still have gigabytes and gigabytes of page cache free, if you set a limit for socket buffers, we don't care that you had tons of page cache free, we still kill you. So this is not really a very intuitive or usable way of operating, and it's mostly because we couldn't retroactively change the kernel APIs. So this is one of the reasons also that the limits were unified in version 2. Version 2 version 2 also is generally more well integrated with subsystems. For example, in version 1, you basically only had one option when you reach a threshold, which was, in the case of the memory subsystem, it was basically kill, which is pretty violent, it's pretty crude. In version 2, we have another threshold called memory.high, which forces you to perform direct reclaim by doing a page table scan on each allocation, which both releases memory, and it also acts as a form of primitive throttling for the process, because every time that you want to do a memory allocation, say with sbreak, you have to go and scan the page table, and you act in kind of a degraded state instead of being kill-9'd. Version 2 is stable as a kernel 4.5, and you can enable it by disabling version 1 with cgroup no v1 equals all, and instructing your init system to mount sysfs cgroup of version 2. Systemd, for example, supports this with systemd.unified cgroup hierarchy on the kernel command line since version 2.2.6. We're running cgroupv2 at scale now on a large number of web servers, and we're already seeing improvements as a result. If you're interested in hearing more about control groups and the internals and design choices that went into the design of version 2, I'm happy to present an open space on this afternoon, so you can come vote for it. You can also come talk to me at the Facebook booth if you so like. If you've used version 1 in the past, I can see that guy over there has, and you found it too difficult to use or reason about, come try out version 2 and let us know what you think. Ta-da.